familiar faces in the audience and a lot of new faces, which is good. I want to first thank everyone for attending the conference. I hope it's been informative for you so far and continues to be that way. I also want to thank Don Matthews for putting together the field trip this afternoon. That's a big undertaking, and all of the ARRA and FHWA people who combined to make this meeting happen. I hope Don's field trip goes a little better than the first one we did out in Utah. For those of us who were at that meeting, we went out to one of our cold replace recycle projects in Nevada. Funny thing, it was snowing that day, so we didn't do much cold recycling that day. So it ended up being a long bus ride for nothing. I'm going to just give you a brief cold in-place recycle overview, and the emphasis I want to make is kind of the evolution of cold recycle as a process. You know, where we started and where we are now. And I think you got a flavor for it with the hot in place folks. You know, what they did 20, 30 years ago is not what they're doing today. And we've coexisted within the Asphalt Recycling and Reclaiming Association. Really good contractors in the hot in place business. And they continue to make that process better from an equipment standpoint, from a specification standpoint, and from a finished product standpoint. And I think it kind of goes along with what we're doing in the cold in place recycle realm of things too. What we did 20 years ago is not what we're doing today. This is just a brief outline of the definition of cold in place recycling, an early history of the process in the West, the types of cold in place recycle trains that were originally used, some of the early limitations to the process that were perceived, and then improvements to the process over time, some of the present day CIR trains, and then some of the advances in the process and the overall growth of the process. And usually I have a barn book handy. I was traveling prior to the meeting and I didn't have a chance to get the ARRA definition of cold in place recycling, so I kind of made this up, so you can shoot holes in it if you want. But it basically just involves milling the existing asphalt surfacing to a specified depth, sizing the milled material in some fashion, and adding various additives, whether it's an emulsion, a foam asphalt process, lime slurry, cement. There's a combination of any of those additives. And then mixing the recycled asphalt material and the additives together and laying and compacting the recycled material. So, you know, hopefully that's fairly accurate. The early cold in place recycle history, there's, you know, people ask, how did the process start? Well, you know, if you ask a guy like Gary Brown from Brown & Brown, or my dad, Charlie Valentine, or somebody from back east, they'd all have a different story of how the process started. I'll give you my story because it was a story that my dad told me a long time ago, and that is that we were on a milling project in California, and this goes way back, so if anybody, Gary, you might remember these things. We were doing a milling project for Frank Pozar, and Frank Pozar was quite an innovator, and he and my dad sat on the side of the road waiting on trucks at the milling machine. We've all been there. Where's all the trucks? And the comment was made, geez, it'd be a whole lot easier if we didn't have to deal with the trucks. Wonder if we could figure out something, you know, in place. So Frank and my dad retired to the tavern, got the cocktail napkin out and started drawing things. Lo and behold, seriously, that's how the process started in the West. We took a milling machine, you know, a crushing unit, which actually our first train was a Pioneer roll crusher. And we still use the same type of plug mills today. We use different types of crushers. But there was nothing that you couldn't buy off the shelf. So that's my story in a second. The process actually started in the early 80s, and over the years, Caltrans has asked, geez, we've never done any cold and place recycling, how come we don't do that? And the answer is, well, yeah, we really did. You just don't know. We did some early projects up on 395 by Four Corners, and then also in Arizona. In the mid-'80s, other states such as Oregon and New Mexico began using the process. And actually, there was quite a bit of work done in Oregon and New Mexico in the mid-'80s to the mid-'90s. Eventually, the Western Federal Lands Highway Division, he's here today, and other Western state DOTs began to use the process as well. And eventually, as we sit here today, all the Western states have specified cold and place recycling at one time or another. The types of the early trains were a multi-unit train consisting of a milling machine. Let's see if my pointer works now. Oh, yeah, I got your head there, John. There's a milling machine, crushing and screening unit, plug mill unit, and that truck there is supplying water and emulsion to the train. Water there, and that is emulsion that's being towed behind the train. And then you have the asphalt paver, one of the rollers, and the other roller is further back in the picture. But that was basically, if you looked at, and I'm kind of keeping my comments to the west because this is a Western regional meeting. Pavement Recycling Systems and Valentine Surfacing Company, Arizona Pavement Profiling, all used a multi-unit frame very similar to this. Early on, some of the limitations to the process, and I think they touched upon it with the hot in place discussion, and that is that with all of these processes, especially early on, there's a little bit more of an art than a science. And it's a little touchy-feely, and some of the agencies really don't like to be in that position. They like to have a specification that you can meet or not meet, and there's something that's measurable. And so early on, there was a lot of trepidation there with the agencies. Trust me, it'll work. And so I think early on it was perceived as a low-volume road process only. You want to be out of the way in the country on a 2-lane road. It doesn't get much traffic, and it'll work. Part of the reason was because early on, with the types of emulsions that were used versus what are used today, the mix was very tender to start with. So you didn't want a lot of traffic on it. That you wanted to give it time to cure out. Many different types of emulsions were used with varying degrees of success. Emulsion, and it continues to be to some degree today, but back then especially, it was very regionalized as far as the type of emulsion that was used. The Northwest has primarily used a CMS product over the years. The Midwest and Southwest were high flows were very prevalent. And in the Arizona, Southern California area, there were emulsified recycling agents and ERA 25, whatever. And so it kind of depended on what geographic area you were bidding to work in as to what emulsion was specified. And also, emulsion application rates were all over the board because there was no mix design. Which brings me to my next point. They were reluctant to specify the process because there was no universally accepted mix design process. There was early attempts at a Rice and a Beam and a Marshall, and it's a very difficult process to apply to a standard hot mix design technology. And typically what would happen is you come up with an emulsion application rate of, say, 3 or 3.5%. And we knew as contractors that we were going to build in a stability problem there because you don't want voids as high as or as low as hot mix. And if you put that much emulsion in, you're going to get lower voids and your stability are going to go out the window. So there was quite a bit of work initially on how to create a mix design that would apply to this process. As a result of that, there was a lot of early research done, primarily in the West, once again, by Dr. Gary Hicks at Oregon State University and Gordon McKean in New Mexico. And they did a lot of very important and informative research projects. Another little known fact is that Oregon Department of Transportation in the 80s and 90s had their own hold-in-place recycled train. A lot of people don't know that. But the maintenance division of Oregon DOT did hundreds of miles of hold-in-place recycle by themselves. And it was almost used as a little bit of an experimental tool. How much is too much emulsion? How much is not enough emulsion? They were actually the first people to use lime in their hold-in-place recycle mix. They spread it dry in front of the train, and that's how we did it 30 years ago. Obviously, that process has changed to a lime slurry with a direct injection into the cutter head. It's a much cleaner process, but Oregon DOT was very instrumental in moving this process forward with a lot of the things that they did. Also, the ARRA contractors, I mentioned some of them earlier, and especially the guys in the Midwest, we all worked very diligently to create specifications for the different agencies so that the process could continue to improve. Obviously, there's also been improvements in equipment and additives. The equipment, and I'll get to that later, a lot of it is the same basic components. You've got a milling machine. In some cases, not all, you've got a crusher and a screen deck. You've got a plug mill. You've got some mixing chamber. So from that standpoint, that hasn't changed. It's just refinements in that equipment. And also changes in the types of emulsions and the change from dry lime to lime slurry is another example. The present day trains, I think the biggest change that we've seen in the industry is you've gone from a multi-unit train that I showed you earlier to what's called a single unit train, where the crusher, screen deck, and plug mill are all on one unit. And what that does is that significantly shortens the length of the train. And as a result of that, it's become a very good process for an urban area because it's a much shorter training equipment. You've got, within those single unit trains, you've got some trains that discharge the processed material in the front, and you've got some that discharge in the rear. You've got, and I'll show you pictures of this, trains that discharge directly into a paver. You've got recycle units with a built-in screed, and you've got recycle units that are capable of utilizing emulsion or foamed asphalt. So there have been quite a few refinements. This is a single unit train, and I might as well plug our ARRA members. This is Darren Coughlin's train with Coughlin Construction out of St. George, Utah. This is a milling machine, and then this unit here has the crusher, screen deck, plug mill, and everything on it. And this is a Rotec train. I'm going to plug everybody here. That is a front discharge single unit train, so that it's very hard to see, but the windrow starts at about that front axle of the recycling unit. So that shortens up things considerably. This is a picture of one of Miller Paving's units in Canada. What this is a Midland mixed paver. And so the processed material drops into the hopper here, and they've got storage on here for emulsion. And there's the screed, they lay it right behind. The use of foamed asphalt is very prevalent in eastern Canada and the northeastern part of the United States. I honestly don't know who this contractor is, so I'm not going to try to guess. But this is a little bit different process where you see he doesn't have any screening and crushing capabilities. He drops the material directly into the paver, and away they go. This is a picture of E.J. Brenneman's unit. They're based out of Pennsylvania, but they work primarily all over the East Coast. And this is another Midland mixed paver. And so the material drops into there, the emulsion's added, and laid behind it. I wanted to show you this picture. This is a pretty good shot of an urban application. And this is actually, if I'm not mistaken, John, is this a foam job?
Yes.
Yeah, this is a foamed asphalt project package, I believe. Toronto, thank you. And this is, on for plugging people, this is a NESCON train. John Nesbitt, with their pavement profiling, has been building these recycle units for years and does a great job at it. I believe, is this a rear discharge? So on this one, the material discharges somewhere back here by the rear end of the machine. And then this is another one of John's trains here, and this is a front discharge. You can see the plug mill right here. The material drops down between the front axles. So there's a windrow that runs all the way down that trailer. John, you might need to help me on this one.
That's the rear discharge train.
You know, do you know whose train that is?
It's municipal CIP.
Okay. In Toronto? Okay. So we've got another Canadian train. By the way, you mentioned my son got married. He married a French Canadian from Toronto, Canada. I won't tell you what Pat Pastor said when he told me. The milling machine drops the material here. The plug mill is right over here. This is the generator. And this material is mixed, conveyed up here and right into the hopper of the paver. So we'll talk about some advances in the process. Virtually all the specifying agencies utilize, and once again, I'm talking about the West. I don't know what the guys in the Midwest needs to do. But all the agencies in the West specify some form of a mixed design process. The advent of engineered emulsions has improved coating characteristics and improved the early strength characteristics. So the mix is much less tender. You can get traffic on it that much earlier, and also you can put your surface course on that much sooner. Additives such as lime and cement have shown to improve the overall quality of the final product. There's really good coating and anti-strip characteristics that those additives bring to the picture. The overall growth of the process, as a result of the continued quality improvement, as well as the advent of the shorter length single unit trains, it's not limited to a low volume road process. There are quite a few projects that have been done on the interstate, and there's quite a few projects that have been done in the city. I know Don Matthews with Pavement Recycling System. There's a number of different cities that have done cold in place or cold central plant recycling in California. There's a number of cities and counties in the Bay Area now that are doing it. So the number of applications for this process has grown substantially. I asked folks at ARRA to give me an idea of how many cold-in-place recycled trains there were in the United States and Canada. And as you know, contractors are very secretive. You know, we've all got the best way to do things, and we're not going to tell anybody else how we do it. And so I got the impression that if they told you how many trains they owned or they used, you know, they probably have to kill you. So this is a guesstimate, but based on what I was able to gather, there's probably over 30 trains in the U.S. and Canada right now that are operating. And I can tell you that every state in the West has performed cold-in-place recycle, and the city and county agencies specifying this process continues to grow. My contact information, I don't know how well you can read it on the screen there. Valentine, WesternPavementSolutions.com. And that's a picture of the middle of nowhere, Nevada. So, anyway, any questions?